Okay everyone, this is the third part of the video on directional angles. So we're going to go over number 65 here, which should be similar to your homework, so it should hopefully help you. This one wants us to find the magnitude and direction angle of this vector right here. So first we're going to find the magnitude. For the magnitude, we're going to use magnitude of V, which is going to equal -2 squared plus 5 squared, and then we're going to take the square root of that, and we're going to get 4 plus 25, which is going to be 29. So it's the square root of 29. Now for the magnitude, that's all we have to do. For the direction angle, we're going to use tangent of theta equals b over a. So we're going to plug in our a and our b. So we're going to get 5 over -2. So now we rewrite it as tangent of theta equals 5 over -2. And we take the inverse tangent of both sides. Inverse tangent. And we get theta equals, now if I take the inverse tangent of this, I get inverse tangent of -5 divided by 2. I get -68.19. -68.19. So once again, we have a negative angle here. We're not going to necessarily use this one. We're going to actually think about, I'm going to draw a picture for you guys so you guys can see why we're going to end up adding this to 180, or you could think of it as 180 minus this angle. If you think about the vector, the -2 and the 5 tell you the direction that it's going, or the coordinates, right, of the terminal point. So this vector has terminal point -2, 1, 2, and 5. 1, 2, 3, 4, 5. So terminal points right here. So this vector is got a terminal point of -2, 5. Okay, but if we notice -68.19, that's an angle over here. So it is telling us the direction of this vector, but it's not telling us the direction in the right, the right direction. It's actually telling us the direction going this way. So this is the other part of the vector right here, but that's if this vector was going in the negative direction. We don't have that here. So this angle, -68.19, is not the angle that would give us the right answer. We actually need to find this angle right here. This blue angle represents the angle that does tell us the right direction, because remember, we always need to start from the positive x-axis and go a counterclockwise direction, and so this angle is going to be telling us the right direction that this vector is going. This red one is telling us for a vector that's going down in this direction. So you can see why we don't want to use this angle. So to figure out the right angle, notice that together the blue and the red here make 180 degrees. So if we want to just know what the blue angle is, then all we need to do is subtract 180. So subtract 68.19 from 180, and that'll leave us with the blue angle. So we're gonna say 180 minus 68.19, and that's gonna equal 111.80. So if you think about it, it kind of goes back to the idea of geometry. You have a straight angle here, or a supplementary angle. The red one we don't want to use, so we're going to take that one away, and we're going to just be left with the blue one. So that blue one is 111.80. So that's the right angle. So our angle is 111.80, and that's our answer right there. So this angle tells us the direction that this vector is going, and just another way of telling direction for vectors. All right, well, hopefully this helped. I do have one more problem to go. So the last one is going to be on finding the component form of a vector. So this one's going to be finding the component form of a vector. So this one is more for a word problem. So in your book, let me go ahead and just look through the book here. In your book here, you have this word problem here. So this is the one we're going to be working on. It says finding the component form of a vector. Find the component form of a vector that represents the velocity of an airplane descending at a speed of 100 miles per hour at an angle of 30 degrees below the horizontal, as shown in figure 6.31. So we're going to try to find the component form of this vector. Right here they're giving us the speed, which you can think of as the magnitude. So the magnitude of this vector, or the length of this vector, is 100, and the angle is 30 degrees below the horizontal, so for a total of 210. So we're going to use this part right here, because if you notice, this part uses the magnitude and angles, and if we go backwards we'll find the component form of this vector. So we're going to use that idea right there. So then if I start writing this, the vector is going to be, we're going to use this equation, cosine of theta I plus magnitude of the vector times sine of theta times j. So using this equation, we'll be able to find the component form. So let's plug in the values that we have. The magnitude in this problem is 100, same thing as the speed of that plane. We were working with 210 degrees, so we're going to plug in 210. And we plug in 100 again, and we're working with 210. Okay, so now we just need to evaluate this. So we have 100 times cosine of 210, that's going to be negative square root of 3 over 2. 100 sine of 210 is negative 1/2. Remember, we still need to know the unit circle. Some of you were asking. Don't just forget about that. So then now we're going to multiply this, and we're going to get negative 50 radical 3 times I, and then we're going to get 50 times j. Now remember that this, we can rewrite it as a component. So to go to a component, we just remove these. So it's going to be negative 50 radical 3 comma negative 50, like that. So today we went in our warm-up from component, or in our lesson we went from component to writing it in linear combination. We can go backwards too and write it this way. And that's it. That's all they wanted, the component form. Alright, so hopefully this helps. We'll continue. Have a good weekend. Bye.